Okay, I don't want to do one of the molecules you have to practice, so we're going to do one that is a separate example of the flashcards. So we're going to do CH4 or methane. And the first thing that I have to do to be able to do this is to draw the Lewis dot structure. Since hydrogen can't go in the middle, carbon does have to go in the middle, and I'll have to put my hydrogens around it. Once I have my molecular arrangement, I'm going to need to find the number of valence electrons in my structure. The way I like to do that is to write out the elements involved. Then I know carbon is in group 14, so it has 4 valence electrons. Hydrogen only has 1 electron, so it has 1 valence electron. 4 plus 4 tells me I have 8 valence electrons to put in my structure. So the next thing I need to do is I need to connect all of the atoms to the center using a plain old single bond. So there's 1, 2, 3, 4 single bonds. That means since each bond is a pair of electrons, I have 2, 4, 6, 8 electrons in the structure, which means actually this is very simple and it is done. In order to do the rest of this, I need to think about the number of areas of electrons only around my center atom. Remember, anything out on the outside atoms doesn't matter to the electron geometry. So an area of electrons is a bond or a lone pair, and we could also call that a group of electrons as well. So I'm going to count just the areas of electrons around the center. So I have 1, 2, 3, 4 areas of electrons. So I'll put 4 for my total number of groups. And then, because I'll need this later, I'm going to figure out whether they are bonding groups or lone pairs. They're all bonds, so all 4 are bonds, and that means none of them have any lone pairs. Now, if I think about this, I know this is not a great representation of the actual molecule itself, because if I look at this now, I would really think that this is a flat molecule, and you would think that it would have a 90-degree bond angle, but it doesn't. We're in a 3-dimensional world, and we can have 3-dimensional molecules. So it's going to get into a 3-dimensional shape that allows these electron pairs to be farther away from each other. I'm going to check and make sure this is the right backside. It is, so I'm going to make a little note of what I'm trying to do here. And now I need to find its electron geometry versus its molecular geometry. The electron geometry only cares about the number of electron groups, nothing else. So since this has 4 areas of electrons, it is tetrahedral. My other options would be 2 that's linear or 3 that's trigonal planar. Then my molecular geometry is going to consider whether those groups are bonds or lone pairs. Under the tetrahedral group, I have the option of tetrahedral or trigonal pyramidal or bent molecular geometry. But this has 4 areas of electrons that are all 4 bonds, so my molecular geometry is also tetrahedral. Anytime I have a tetrahedral molecule, it's based off that 109.5-degree angle in a 3-dimensional shape. The problem with my Lewis structure on the front is not that it's incorrect, it's that it's not a very good example of the real angles in the molecule. So what you want to do on the back here is to use this information to draw a new Lewis structure that's a better representation of the actual angles, like 120 for trigonal planar, or this 109.5. So I'm going to start by kind of basically getting set up for my Lewis dot structure. And since I know this is 3D, I'm going to use a little technique to try and make it look a little more 3D. And if I draw a solid, plain old everyday line, that tells me that that bond is planar with the center atom. It's flat with the center atom. So something that's, say, trigonal planar would all be straight lines. But since this is 3-dimensional, one of these bonds will be coming out of the page. It'll be coming towards you, poking out. And I'll use the dashes here to show something that's coming back into the page or away from you. It doesn't really matter which ones you pick to make the dash, the wedge, or the solid, as long as you have 2 solids, 1 wedge, and 1 dash for a area with 4 electrons. So there's my 2 planar bonds. Those are the ones that are flat with the center atom. And then now I know I need to have 1 wedge coming out of the page pointing out at me, and 1 dash arrow that goes back away from me. So this makes a better look at it because it doesn't look like the angle is only 90 degrees now. Now it looks like that angle is a more correct 109.5 degrees. So that's the idea of what you're going to be doing with these flashcards. Once you determine their geometry on the back, you're going to draw it in a way that makes a better, more accurate shape.